Welcome. I want to give you a full walkthrough of Lab 2. It's kind of a tricky lab when you first see it. There's a lot to understand. So let's get started. If I go out to GitHub, the link that I gave you in the lab, hello, clone that repository, and I'm bringing it down, and it's going to tell me it's not empty. That figures. And I'm going to make it empty. Lab2 starter. Okay. Alright, I'm going to import my work. Alright, here we go. So I have Lab2 started on. You'll go through and disconnect it and then reconnect it. I'm getting an error. Let's see what that error says. I'm getting an error. Is it a build path error? It has test resources missing. That's interesting. It could be that I had something under resources that was missing. Let's do this in case you get the same error. Let's just zap those things under. It was under test resources. Oh, I see. Okay, so the directory test resources isn't there. That's my fault. So let me fix that real quick. I'm going to say new folder source test resources. There we go. Okay. So when I committed it, that folder had no files in it. Remember I said if GitHub doesn't have, if you don't have a folder under it, it won't commit it. So that's what happened. Just so that doesn't happen to you, I'm going to put a blank package in there. Package test. And then I'll go through and recommit that so you don't get that same error. Okay, so it's going to commit and right on. So you're back to normal. All right, so I've got a Maven project. Maven project has start with source main Java. I've got package poker BLL and package poker enum. Let's start with the enums first. The enum is a way to have code and context come together. So instead of just having values that have no context around them, the enum, the enumerator, allows me to add context to code. So if I said something like within this, if I said eCard no dot, so I'm gonna think there for a second, eCard no dot second card. Let's see. Okay, well, yeah, of course I gotta say eCard. Right? So I can, if I see that in code, I know that E really means the second card. But the ordinal value for that is 1. But I don't want to have to say that. That won't make any sense. Like, in other words, if I just said int E equals 1, it sort of loses meaning. All right, so enumerators. The way enumerators work, at the beginning, after the class declaration, I have a list, a comma-separated, semicolon-ended list of things. Now, when I do this, I'm passing in a value into its constructor. So what happens is there's a private constructor for this, and it passes over a final value called card number, and it sets this card number equal to card number. This private int card number really should sit here to make sense. In other words, if we want it in the order that we normally get, it's the attributes, then constructor, then getter. So that may make a little bit more sense. I've got an enum for rank. This one's a little bit easier to understand. Rank, these are the cards, 2 through Joker. And just for grins, I'm going to get rid of Joker because that's not a part of this this class just yet. Joker's Lab 3. but nothing that we haven't seen. It's got an attribute, it's got a constructor, it's got a getter. Suit has Joker too, so let me get rid of Joker. Goodbye, Joker. Okay. Hand strength. Now this gets a little bit tricky about hand strength. We're going to go back to this, how hand strength works. Hand strength. Remember the whatchamacallit, the values that we're going to use for the enum are comma separated. So royal flush comma separated, straight flush comma separated. But within that, I'm doing a couple of things. First, I'm passing over two values over to its constructor, and on top of that, I'm overriding the toString function for that enum. So if I ask to print that enum, instead of printing royal flush with no spaces, it's going to print royal flush with a space, and you'll see that later on. All right, so let's we'll go back to the enums, and when we start looking at the code, I think it'll make more sense. Let's go to card. This is a single card that's in the deck. Single card in the deck has two attributes. It has rank and suit, which are mapped to enumerators, rank and suit here, rank and suit. If I do it like this, that means I can't build a card with a 55 value or 55 rank. I can't create a card with an eagle suit, right? It has to be the four suits that I had defined. I've got the attributes. I got a constructor, getters and setters. I've got a compare to. Okay, this compare to allows me to. What I did was I interfaced with the comparable interface, and I have a compare to implemented for that. I also have a comparator. So we have a compare to, and we have a comparator. The difference between the two, if I wanted to have an alternate way to sort, I can do it with a comparator. So I will get into the alternate way to sort later, but if I wanted to sort it by, this is just sorting it by rank, but if I wanted to sort it by rank or rank suit, I'd have a compare and then a comparator to do card rank suit. The way it looks now is it is literally just ranking rank. So for all intents and purposes, this and this are essentially doing the same thing, ranking it by rank. In deck is a one-to-many relationship between deck and card. For one deck, you have an array list of cards. So the only two attributes you have for deck is deck ID, which is UUID. A UUID stands for Universally Unique Identifier. And then deck cards, which is an array list of cards. Now, when the class is first started, that array list is initialized. In other words, there's nothing in that array list other than the 10 positions that are by default added for it. What I expect to do is when I call the deck constructor is going to build up that deck cards. When this deck constructor is done, two things are going to be done. Deck cards is going to have 52 cards in it, and the deck is shuffled. So it's not that much lines of code. It's probably 6 lines of code. This is an example. This is a good hint how to get started. If I was going to build up that deck, I know I have 4 ranks, and I know I have I know I have 12 ranks, and I know I have 4 suits. So if I do this, rank is rank.values, I can iterate around rank. This is a for each loop around rank. Every time I iterate around this, I'm going to be able to pull rank. And that rank is going to be 2 through ace, and then 2 through ace, 2 through ace, 2 through ace. So this is a for loop for 12 runs. Well, if I did the next one, if I had a nested for loop, in other words, I had a for rank, and inside that for rank had a for each for suit, 12 times 4. 12 times 4. That's 12. It's 13 ranks. My fault. 13 times 4 is 52. So to do the deck build up, you do a nested for loop, one for rank, one for suit. And when you're in the inner part of that for loop, add a card to deck cards. At the end of that nested for loop, I'll give you the line of code. It's not that hard. Collections dot shuffle deck cards. That'll do it. Collections dot shuffle. Shuffle is interfaces with anything that is extended from list, which array list is extended from list, you pass it in an array, it'll pass back those elements in shuffled order, in random order. You literally have like 4 lines, not even 4, 2 or 3 lines of code to finish this up. Draw a card. Drawing a card, what I want to do is I want to say card C, let's say card C equals deck cards at get 0 position. In other words, get the top card. Then I want to say deck cards dot remove, and I want to remove at 0 position. And then I want to say return C. Those 3 statements. Well, don't really need 3 statements. I could probably refactor this to do it in less statements than 3. I really didn't need to create a new instance of C. And I know that if I do a deck cards.remove 0, it will remove that 0 card, but before it removes it, it returns it. I could have said this, deck C or card C equals deck cards.remove. When this remove is complete, C has that card. And if I look closely, I really don't even need to do that. I could have just said that. 1 line of code. Return deck cards remove at 0. That's going to remove it, return the card that was removed back to the caller. Deck's not that tricky. Let me close this. I'm not going to save it. You're going to have to do that yourself. Let's go out to hand score. Nothing to do here. Read through it if you want to, but it's nothing to do here. What I'm doing here is the hand is scored 4 ways for 4 tiebreakers. The hand strength, the high hand, the low hand, the kickers. This would be like royal flush, straight flush, 4 of a kind. High hand will tell me, let's say it was 4 aces and a king. High hand would be ace, and kickers would be 1 king. If I had a pair of 7s and a pair of 5s with a 2, high hand would be pair of 7s, low hand would be pair of 5s, there'd be 1 kicker over 2. This is how the hand is scored. But no changes in this class. Player, no changes in this class. So I promise you're going to do it later. No changes in this class. Table, I asked you to add a player to the table. This should be pretty easy. This is like literally 1 line of code. You're passing in a player. P, you've already got a table set. You've got a table, a table object, and you've got table players. You should just say table players.add and pass in P, and that'll do it. All right. Toughest one is hand. And I'm going to pause this, and I want to start a new video to explain hand because it's a tricky one. I'll be back.